Hello and welcome back to Precalculus CP. Today we will talk about 5.2, the sum and difference formulas, and you notice we get to verify identities again. Okay, there's a lot of writing with these formulas, so in the very first one I'm just going to highlight some things, and let me see if I can use my pointer. Very good. Okay, so you are going to be finding exact values. That's the whole point of sum and difference formulas. So you can find exact values that include square roots, which your calculator would just give you rounded decimals. So if you look, many times we ask you to memorize these formulas so that they get into your brain and you see the patterns, but let me just point out a few patterns. First of all, when we're talking about a sum and a difference formula, it's because the angle is either a sum, a plus, or a difference. Now, if we have two formulas, if it's a sine of the sum, it's going to be the sine of the cosine plus cosine sine of the two different angles. Notice the angles are always in order. You can say A and B if you want, but they're always alpha, beta, alpha, beta. If you have a difference, then you have a difference in the sine formula. Then when you get to the cosines, we call them cos and sine. But notice you have a plus here and a minus here, and here you have a minus here and a plus here. So those are opposite signs. The tangents, a little more complicated, and we get to do complex fractions again sometimes. But notice if it's a plus here, it's a plus there. And then it changes sign for the denominator. Here we have a minus here, a minus here. It changes signs for the denominator. So look at the patterns. It's good to memorize them and get them into your head so that you recognize them right away. Now for the rest of this page, it's basically just filling in formulas, but I do want to point a few things out. First of all, you do have to remember all of your sine, cosine, tangent of 30, 60, 45. You have to be aware of a smart trig class, in other words, the positive and negative signs in each quadrant. And I do want to point one thing out. When you are substituting the formula, as long as it's the formula, the cosines and the sines are still in it, but as soon as you start to substitute, don't make the mistake I often see students do of saying, instead of square root of 2 over 2, saying cosine of square root of 2 over 2. I mean, it's the cosine of an angle equals square root of 2 over 2. And compare your answers to these solutions and you'll see that. So basically what's happening here is you're getting exact values for trig values that we would not normally be able to get exact values for just by rewriting them as a sum or difference. Okay, now that group takes a lot of writing, but I wanted to show more detail on the verifying identities because this particular problem, here, many students get wrong, and it's really a shame because they're not that hard to do. All you do is follow the formula and everything works out. So I'd like you to pay close attention to it, both on the test and on the final exam. Students get these wrong, and you're just using the formula. Sometimes maybe I think you get confused because this looks kind of like, this kind of looks like a cofunction. Maybe that's the issue. I don't know. But you could prove the cofunction formulas using difference formulas. But we're just going to actually use the formula. You look at your formula sheet, you have a cosine of A minus B. And here you have a sine. This is the cosine. I'm writing a little bit more here for clarity. Here you have the sine of A minus B. You don't have to write all these steps if you don't want to. And you're just going to go fill in the formula with A is pi over 2 and B is theta. So make sure you show this step. Don't just jump to the end. you have to, especially when it's something simple like this, or sometimes it's even a zero, you have to show that you can get everything by doing it step by step. So you're going to do cos cos plus sine sine. So you have the cos of pi over 2 times the cos of theta. Right now, just fill them in. We'll deal with what they equal later. Plus the sine of pi over 2 sine of theta. Okay, that's the first one. Now I'm going to change colors for the second one, because sometimes people just forget that you have to do completely, expand completely each one. This time A is pi and B is still theta. So we're going to do plus sine of pi cosine theta. And we keep the subtraction minus cosine of pi sine of theta. I'm getting a little squished here, but we'll deal with that. Okay, let me go back to purple. Okay. All right, so now is our task of filling in the ones that we know. Obviously, if it's cosine of theta, we don't know what that is, so we're going to have to leave that as a variable. And notice there's a sine of theta on the right anyway, 2 sine theta, so we want to keep some thetas in there. But we have to write in the exact values of what the cosine of pi over 2, etc. are. So I'm going to look at, if you notice, let me just take you over here and look at the chart here. Remember, when you have quadrantal angles, you have to go back to the unit circle. You have to remember what the 4 unit ordered pairs are at the quadrantal angles, and remember that for each section, x is the cosine and y is the sine of the ordered pairs. This is the unit circle. So for the cosine of pi over 2, we go up to pi over 2, and the x is 0, so it is going to be a 0. And of course we don't know what cosine of pi theta is, so we leave that there. And then sine of pi over 2 is the y-coordinate, which is a 1. And I'll change back to my red here. Sine of pi, so you go to the sine, and that y-coordinate is 0. So 0 times cosine of theta. Cosine of pi is -1, so we careful with your minus. So we have a minus and a -1 sine of theta. Excuse my sloppy writing. Okay, so what happens here is our the zeros. 0 times anything is 0, so that cancels out. 0 times anything is 0, and you end up with sine theta minus a negative, so it's plus sine theta. Make sure you do a couple of these totally on your own and realize that you are well able to do these, as long as you know your quadrantal angles. Okay, so that's the problem that people have problems with. Then the other kind of verifying identities is when you just have a sum or difference formula in there, and then it becomes just like what we did in the last unit. So I've substituted this one already, cos cos plus sine sine. And then we'll continue. Now this is that strategy we talked about before, where if you have a fraction on the left and 2 separate terms that are added on the right, you're going to have to separate the fraction. So I'll try and see if I can write faster here. So we're going to separate this into 2 fractions, and both with the denominator cos alpha sine beta. And then you'll see what we can do. And once again, if you don't like writing alphas and betas, feel free to write a's and b's instead. As long as you're consistent, you have to keep it all consistent if you're going to change anything. So you have, here we have cosine over cosine that cancels out. Now be careful that the angles are the same, but they are. They're both alpha. And here's two that are sine beta. So then we end up with a final answer. Cosine over sine is cotangent of beta. It's not nice. Okay, let's try that again. Cotangent of beta. And then we have sine over cosine is tangent, and that's the alpha. And I'm not even going to rewrite that because we all know the commutative property, so we're going to let that go. Okay, so that's not too bad a proof. Don't get scared when you see the word proof. Now this problem, number 3, you need to keep your formula sheet by your side because they're very simple formulas. I mean, very simple problems once you realize what's going on here. So you're always going to use exact values, remember. We never use decimals in any of this. And when you see a cos minus a sine. So you look at your formula sheet and you see that you have this formula, cos of alpha, cos beta, minus sine alpha, sine beta. So what we're going to do is we're going to write that as cos of alpha plus beta. So you're going to consolidate this together, and your alpha is pi over 16, and your beta is 3 pi over 16. Now you have to simplify. That's the rules. And that turns out to be 4 pi over 16, which is the cosine of pi over 4. Now at this point, if it's not what we call familiar, then you just stop. Like if it were cosine of 25, you don't know that, so you just stop. But if it were cosine of 30, you write an answer. So that's the rules. If it's cosine of pi over 4, we know what that is. Remember, this is second nature to you. That's just square root of 2 over 2. And then we're done. Okay? And last one, when you're using the formulas, it involves a lot of writing as well. So I have my little pointer here. I'm going to point out things on this last one for you. The work is all done here. So the job is to look at what you're given. And let me just circle that here. You're going to be given a tangent and what quadrant, and the cosine and what quadrant. It's not always a tangent and cosine, but it'll be some trig function and what quadrant it's in. So you know the formulas involve more than you. By the way, if you look in the book, this is number 60. They all have parts A, B, and C. A is to do the cosine of the sum, B is the sine, C is the tangent. So you're going to need to know cosine, sine, and tangent for alpha and also for beta. So look at what quadrant it is. Once again, remember that in quadrant 2, the x's are negative, the y's are positive. That's very important when you see, let me get my pointer out here. That's very important when you see a negative 4 over 3 for a tangent, because that's where your knowledge tells you you have to put the negative somewhere, because the 4 is the opposite, the 3 is the adjacent, but because of your knowledge, you know that in quadrant 2, the x's are negative, so that's why you're going to put the negative with the 3 and the positive 4. We never make the radius positive. The radius is a length, a distance, and it's always positive. And then in the other triangle, you're going to do this background work, and you always get credit for all the work you do. So this all has to be shown that you draw the angle in the quadrant, and you solve for the missing side, which in this case is the b, a squared plus b squared equals c squared, and then you find that your cosine, sine, and tangents you have written out here. I like to do them all at once because I know I'll need them later. If you want to find them as you need them, that's up to you. So if you notice, and once again, this is students, for some reason I think you just get overwhelmed at times, but here is the formula, cos minus sine. But when you put the numbers in, the coses are no longer there. The cos of this angle is negative 3 over 5. That's adjacent over hypotenuse. Negative 3 over 5. The sine of it, the cosine of b, or about beta, cosine of beta is 2 over 3. Notice you are not finding the angles. That is not, if you do that, you will get answers that are decimal answers, and they are not accurate as exact square roots. And then you have the minus from the formula, and then you fill in the 4/5 and the square root of 5 over 3. And once again, the denominators are always common denominators because the hypotenuse is the same for sine and cosine. And then the numbers on up top you combine. And I don't think there's anything different for me to tell you about the sign, but just make sure you're doing them all and getting them right. I did want to mention a couple of things for the tangent. Watch out, if it's a plus, your top's going to be plus, your bottom's going to be minus. So what I have in green here are the values. Watch out for the minus and negative, or if it was a minus, negative, and a negative, that would be 3 negatives. You may not leave this green section as a complex fraction. We have to make it into one fraction. So I showed the method here of combining the fractions in the top to make one denominator, which is a 6, and combining the fractions in the bottom to make one denominator, which is a 6. I didn't write out the step of taking the numerator times the reciprocal of the denominator, because for me it's very easy to see that if you have the LCD method in your head as well, you could actually multiply the top by 6, and that cancels out the 6. And you multiply the bottom by 6, and cancels out the 6. So, however you come up with that, this would be your final answer. And the book is leaving them like that, so check with your teacher if you can just leave that in the denominator. Okay, that's all the detail, and I hope you have fun.